Hi everyone, today we're going to solve the 2015 paper 3 question 4 on the Maths A-level paper, so the 2015 paper. So the question tells us that the equation x cubed minus x squared minus 6 is 0 has one real root denoted by alpha, where, remember guys, the root is where the graph of x cubed minus x squared minus 6 intersects the x-axis. So x-axis right here. Y equals 0, sorry. So find by calculation the pair of consecutive integers, so we are told they are integers and they are consecutive, between which alpha lies. So if you followed what I said just now, we have to find the integers between which, so if I draw a quick x-axis here, right here, so this is alpha, and then you have here, you have two values of x, so you have x1 and x2, and x1 and x2 will be two consecutive integers. So clearly there's a change in sign, and that's exactly what we would exploit. So let's start. Right, so x cubed minus x squared minus 6 equals 0, that's the equation, and I shall call it fx equals 0. So fx equals to x cubed minus x squared minus 6. Right, so we know it has one real root, and then you can start trying some integers, and essentially what you want to find is that you want f of x1 times f of x1 plus 1 to be less than 0, because you want this to be, you want there to be a sign change, indicating that the graph of fx crosses the x-axis. So that's what you want to find. And you want to find x1 and x1 plus 1 in order to answer the question. Right, so how do we do this? Well, we can try substituting in values, and I started with x equals 1. If you put 1 in here, so 1 minus 1 gives you minus 2, minus 6, so this is minus 8, and then you try x equals to 2 here, and f of 2 gives minus 2, so it's not between 1 and 2. But now when you try 3, f of 3 equals 12, so you can see that there is a sign change. And because fx is smooth, and by smooth I mean it's obviously a continuous graph, for these purposes smooth is enough, well, we can characterize smooth by this, we can say that alpha has to lie between 2 and 3, so fx. This is exactly what we said. Oops, I'll jump that here. There we go. So alpha is between 2 and 3. So that answers the first part of the question. Very easy. So second part is that show that if a sequence of values given by the iterative formula as shown here converges, then it converges to alpha. So essentially they're asking us to either show that this equation is essentially solving our problem here, or that we can do the reverse and prove that we can obtain this equation right here from our problem here. So there are two ways to approach this problem, and I think here it's easier to start with the iterative solution. So starting with this, you just drop the subscripts, so you obtain x squared equals x plus 6 over x, and you obtain this, so which is the original equation, which I denoted by f of x equals 0. There you go. Therefore, if this scheme converges, then it will converge to the root alpha. And you might ask yourself, why is that? Like, how does that work? Well, imagine plotting the left-hand side of this and the right-hand side of this. So here. So you plot the left-hand side and the right-hand side. And this is exactly what I do. So how do you plot? Well, you know how to plot y equals x, and how do you plot this graph? Well, you can start by sort of imagining what happens as x tends to very large values and as x goes to 0. So when x goes to infinity, this thing, so x plus 6 over x, the whole thing square root, tends to infinity. Because this part tends to 0, and this tends to a huge number, so it will go to infinity. When x equals 0, this is 0, so this goes out, but then you have a huge number here, so it tends to infinity. And there you go, I plotted the graphs, and this is y equals x, and this is the square rooted term. So essentially what you're doing when you're saying x of n plus 1 equals x plus 6 over x, n, is you're picking a starting point, which is here arbitrary. Say you start here, so start, let me use another color. Well, I used, okay, let's use blue and make it thick. There we go. So let's start here, and so you plug this value here, you plug that into the right hand side, which is here. Right, so how do you plug that? Well, you go to the curve and you obtain a certain value for y. Right, and then you say that, well, what is that value? Well, it's this, right here. Right, and then you take this value now, you take the value, so you started at x0 and you end up with x1. Right, and then using x1 you plug it back into the right hand side, so you go here, and so this is x1, and you go back to the curve, which would be somewhere here. Right, so this is x2, and you repeat this process. So essentially you repeat this. So you go there, 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 like this, and you end up at alpha. So this is why it converges to alpha. Sorry, let's get rid of this line and get rid of that line. That makes it less confusing. And there you go. So this is the path that you follow, right? And this is why you converge to alpha. Okay, and I think, so this part is solved, and that was just the explanation as to why this works. And now, but you don't need to know this actually for A-levels. I've never seen a question ask this. And now the third part is using this iterative formula, determine alpha correct to 3 decimal places. So this is very important, 3 decimal places. And give a result of each iteration to 5 decimal places. Okay, so there's a few things here. So they just want us to use the formula, right? And that's exactly what you need to do. Well, you already know that alpha lies between 2 and 3 from the first part of the question, so a good initial guess would be x naught equals 2. Or you could pick x naught equals 3, but I wouldn't start outside of these. Right? So then you put 2 into here, and you obtain this value. You put it back into the right hand side, you get this value, and you carry on until you see that there's no further change, at least to 3 decimal places. And remember guys, 5 decimal places for each iteration. Right? So from here you get that alpha equals 2.219, and in order to check this, well, you can do the exact same trick as before, as you used in the part 1 of the question. So f, because they want their answer to 3 decimal places, then f of alpha minus 0.0005 multiplied by f of alpha plus 0.0005 has to be less than 0. So it has to change sign between those two values. And that's exactly what I write. So to confirm that we are correct to 3 decimal places, we need to show that f of alpha plus 0.005 times f of alpha minus 0.005 is less than 0. So what we're saying is, if you plot a graph on the x-axis, and this is exactly alpha, so the graph would cut here, and this is alpha minus 0.0005, this is alpha plus 0.0005, then you would obtain something which looks a bit like this. Or it might be the other way. Either way doesn't matter. What matters is that the product of f evaluated at this point and f evaluated at this point is bound to be negative if we are correct. So you try it. So f of 2.2185 multiplied by f of 2.2195, and you put that in the calculator, and you indeed obtain a negative answer. So indeed, to 3 decimal places, alpha is 2.219. Because whatever you round from here and whatever you round from here is always going to be 2.219. That's it. There we go, and see you next time.